Hi guys, do you hear me? Okay. All right, great. So my name is ANDREI ANISIMOV. I work at ABase. We are a founding member of GraphQL Foundation. And today we're going to talk about exposing Salesforce data through GraphQL. Okay, but first let's talk about why this is important at all. So if you think about sort of over the last maybe 10, 20 years, we have ubiquity of consumer apps, and regular people get more and more accustomed to amazing experiences with these apps. When you use Uber, when you use Airbnb or Facebook, you're used to that sleek UI, great interactions, etc. And so that's how people increasingly view businesses. They view them through the digital interactions with businesses. So if the app is the only way for you to interact, let's say, with a bank, then your whole perception about the bank will be defined by your experience with this app. Yet when it comes to sort of digital transformation, we still building external consumer-facing apps, same way we built them maybe 10 years ago. We still have to basically define a custom API. We have to write a client that consumes this API. If the data sits in multiple different data stores, we have to have some type of middleware integration engine. So in other words, it's pretty much same. There is not much progress there. While at the same time, digital transformation when it comes to internal applications for employees, it's been doing pretty well, and we all know that there are tons of apps that internally people consume to make their sort of business processes more streamlined. But yet the difference between externally facing applications and internally facing applications is that when it comes to externally facing applications, there is much more sort of like emphasis on the UI, on the branding. So it's pretty hard to sort of do some type of template app that will auto-generate all the screens. You still need front-end developers to build a custom UI. But now the front-end developer somehow needs to get all this data out of your enterprise sort of data graph. And the modern enterprise data graph, it's becoming increasingly complex because you now have multiple different systems that store data. Data is very fragmented. It's relational in its nature, but these relationships are not explicitly defined. Then every system has separate API that you need to learn and understand in order to be able to create an integration and expose this data outside to the front-end developers. And then you also have security issues and other similar problems. So basically, burden is on the front-end developers and middleware engineers to make it all happen. And so we're gonna pick Salesforce as the backend system that we want to take data from and expose it to the front-end application. And why Salesforce? Salesforce is arguably the largest concentration of customer data in the world. It's number one CRM, and often when you want to build some type of customer portal, you need to present customer data there. And now, why GraphQL, right? How GraphQL is uniquely positioned to solve this problem. And the reasons why GraphQL is because, first of all, GraphQL is composable. So it allows you to compose different data sources, stitch them together, and not just sort of stitch them together in a flat sense, like REST, you have a bunch of resources. You can create a graph, which is like enterprise data graph, where you can explicitly define relationships between all your different entities in your business model, and those entities can live across different systems, yet can be consumed by a front-end developer as a single graph without necessarily even knowing where the data is coming from. And then also the GraphQL is open standard, meaning that as a front-end developer or mobile developer, once you learn it, you don't have to sort of relearn it again and again for different kind of systems, different kind of data. If you consume Salesforce data through GraphQL, you might as well just consume SAP data, Workday data, whatever you need. So with that, let's just take a look at a very simple app that takes advantage of sort of consuming data from multiple sources, including Salesforce, and see how it works from the perspective of developer experience of the front-end developer. So the goal of this talk is sort of show how in the future with the proliferation of GraphQL and different integration engines that allow you to configure GraphQL API declaratively or through configuration without writing any code, how you can really improve developer experience of people sort of at the front lines who build these customer experiences. All right, and with that, we're gonna switch to the browser, and the app we're gonna show is extremely simple. It's basically, the use case is the following. You have customer data inside of Salesforce, and you are an insurance agency, so you sell insurance policies. And Salesforce has custom modules that actually allow you to run insurance business on top of it. So people store insurance policies in Salesforce. So this is my Salesforce development instance that already has policies custom object defined. It has accounts, which customer accounts, and then the policy has a relationship with customer account. And so what we want to do is we want to, presently we have customers email us or they call us and say, hey, when is my policy expiring, or how can I submit a claim? We want to build a customer-facing app that allows people to self-service to this. And so the app is not designed at all, but functionally it works like this. It presents the customer information. It presents list of the policies that they have, and then they can submit a claim. And the claim appears here. And then if salespeople sell another policy to this customer, then the policy should appear here and the customer see when it expires. So of course we can design it, we can make a mobile app out of it. It doesn't really matter. It's irrelevant for the purpose of this talk. We sort of focusing on the data here. So let's look how it works under the hood. As an integration engine, we're gonna be using 8-base. We recently released a feature where we allow to integrate with Salesforce, and in the future multiple other data sources, and then also define your custom tables and define relationships between all this data living in different systems. So I'm going to show how it's all possible. So under the hood, this is a simple React application. All the logic here is defined in a single JS file. We have several GraphQL queries here, and a little bit later I'm going to show how I configure this. But first, we take the current user, and then we look at their Salesforce account. So account is the relationship that looks directly inside of Salesforce, and it takes data from there in real time. And then it automatically it interrogates the Salesforce data model, and it knows, for example, that account has a name field, and then it has a policies relationship, and then the policies it's a table, and it has different fields inside of this table. And the fields that have __C, it just means custom fields that I defined. That's how Salesforce does it. We have the profile query that takes the user information and list of their policies. We have the claims query that takes a policy by ID and renders the list of claims that were submitted for that specific policy. And as you can see, the interesting thing here, and that's where the sort of the beauty of relational data graph of GraphQL comes in, that the policy object lives in Salesforce, but the claims object lives inside of 8-base. Or it can live in a custom database. It doesn't really matter. But the cool thing is that this child object actually lives inside of a different system. But yet for front-end developers, it just they simply get the data they need without really even knowing where the data is coming from. And then the third query you have, it's actually a mutation. It allows us to create a claim and link it by policy ID to the policy inside of Salesforce. Okay, and then we use Apollo client here. So the application is already pre-configured with a standard Apollo client. It also has in-memory caching enabled, and pretty much it. And plus authentication powered by Auth0. So here we just use this simple, we use the useQuery hook, which is provided by React Apollo, to load the profile data and render email and name of the user. And then the same, very similar way, we use the same exact query to render a list of policies. And interesting that, even though we use the same query twice, there is actually only one request because Apollo client does the caching under the hood. And if the query is already in cache, then it just takes it from cache. It doesn't query the server again. We'll render a list of policies. Here, same way we render list of claims, again using the use query hook, and claims query for specific policy that we selected. And then the last component we have is a new claim form, which is just a form with a single description field that allows you to create a new claim. So this logic is very, very simple. There is a minimum amount of boilerplate here. What's cool about GraphQL and Apollo is that it really abstracts away all the regular boilerplate you need to write, let's say with something like Redux, and allows you to focus on the core business logic that's unique to your application. And then we have this sort of parent component that just renders all these subcomponents together, basically. That's it. That's all the file that defines this application. And now, let's see if we, for example, if we wanted to go and add another policy to Salesforce, and we select this account, start date, end date. We save it. It's linked to our account. Let's see if we refresh it. Then now we have two policies. And now we can select which one we want to submit the claim for. Okay, so now let's see how a front-end developer using A-Base could just configure this API without writing almost no code on the backend. Okay, so this is the A-Base UI. It has the Salesforce configuration, Salesforce integration enabled here. It simply just gives access to my Salesforce instance here. And what it allows me to do is I can now bring in any table from inside Salesforce. So let's say I have a contact table already exposed here. I'm going to delete it. And then I can just re-import it again. Contact. And now I can operate with this table as if it's a local table. I can add new fields to it. I can create relationships between this table and other tables, and basically just visually build this data graph that I need. So for example, how do we link user account in 8-Base to Salesforce account, right? We simply, so this is user table. It's a system 8-Base table that simply represents the currently logged in user, or all users in the system, right? So we just drag the account table on it. We define the nature of relationships, and it's going to be one-to-one. Each user in 8-Base will have a corresponding account in Salesforce. We're going to save that field. And then here we also created a custom claims table. Let me just delete it and recreate it again, just so you can see how it's done. Claims, description. It's a field of type text, and we can define many more fields. And then we can connect claim to a specific policy. And the reason why I created claim table not inside of Salesforce but inside of this application is because usually in businesses, Salesforce is sort of like holy grail. It's like a thing that nobody can touch because it's very expensive. The Salesforce developers are very expensive, so they paid a lot of money to configure the Salesforce instance. And now nobody can touch it because if it breaks, it's a core system. If you can't look up customer data or if something gets screwed up, the whole business will be impacted. So they not necessarily want to give maybe it's a contractor front-end developer who's building the app, and they don't want to give them access to mess with Salesforce. So that's why you define this table in a separate system, and then you just basically link it to the Salesforce table. And now you can define the nature of this relationship. You can say it's allow multiple claims per policy. Okay, awesome, looks good. We save it. And that's what allows us to connect these tables that live in multiple different places. Okay, so this automatically builds a GraphQL API for us. So now we can say something like user, take the email of the user in Salesforce. And then we can take their ID inside of A-base, their email, their associated Salesforce account. And then from that Salesforce account, we can take their name, maybe some other information if we want to, and then we can take their policies, because this relationship is defined directly inside of Salesforce. And then from each policy, we can query its fields, start date, end date. And also we can get a list of claims for this policy. Even though the claims live, so we sort of have this circular relationship. First we relate local object with remote Salesforce object, and then we relate it back to a local claims object, which is pretty cool, which I think is why GraphQL is uniquely positioned to solve that problem. So take a claim and description. Now let's see what happens. ANDREI 2, second. Let me make sure it's, oh, I know what happened. Because I deleted that relationship, it now lost the association. So let me just delete that user, change this email here, so I can log in as if it's a new user who uses the system for the first time. Okay, I'm gonna sign out, and that's the experience of a customer who signs up in the system for the first time. And again, you don't need to use Auth0 necessarily. It's just to make it sort of quick. We can sign up. Okay, cool. So now I see my policies. And now if I go in 8-base and refresh list of users, I can see this new user, and they have associated Salesforce account. So this account is a relationship to Salesforce account. But the only thing is, how does 8-base magically knows that this user is associated with that Salesforce account? Well, that's where we have to write a little bit of backend logic. And this logic looks like this. This is a Lambda function that gets triggered every time a new user is created, and it gets deployed inside of like sort of 8-base execution environment, which is powered by AWS Lambda. And here we simply take the email from the payload of this new user, and using the GraphQL schema, we just use the field connect. We connect an account inside of Salesforce based on this field. So what it's going to do is going to find Salesforce account with this email, and it's going to establish relationship between this new user and that account. So that's all the backend logic that we need to write in order to enable that. And that's it, pretty much. We have the application. Now we can submit, the customers can submit claims. Obviously, it can be much more complex than this. Description of claim. And very, very easy to build this app. And now what's even cooler is because there is a bunch of sort of tools for front-end IDE plugins, etc., powered by Apollo or some other open source projects that make experience of front-end developers really cool. for example, the autocomplete. So let's say maybe I want to render a phone number of the user, right? So I press Control Space and I see all the fields that exist inside of Salesforce for this object. And I can add a phone. And then I can change my component here. And now I have the phone. There is no phone for this user. But if I add it here, still no phone for this user, huh? Phone 11, something, see, something is not data user account, phone, oh, okay, it's capital. Okay, awesome, I have it. So as you can see, it's pretty simple. You don't need to hire any backend developers. And then potentially, if you think about it, that for 8base, doing this sort of middleware is a business, which means we can invest money into something like, for example, making sure that our definitions are in sync with your Salesforce data. So when you change something to Salesforce, it will automatically reconfigure it, or maybe it will alert you, hey, you know, there is an inconsistency because there is no such table anymore there. And you know, do all bunch of neat things that sort of at scale make sense, but as an individual small medium business, especially if technology is not your core competency, it becomes pretty challenging and pretty expensive. And that's sort of like, if you think about it, that's the main reason why sort of most business apps kind of lacking, so to speak, comparing to consumer apps, is because businesses, they cannot recruit the best of the best developers to do this stuff. So going back to our presentation to conclude it, so how is this better, right? First of all, it's very fast development. You can put together such application very quickly. You don't need to learn Salesforce API. You don't need to think about authentication when it comes to like separate authentication for Salesforce. You don't need to maintain this middleware and hire specialized Salesforce developers. And then the front-end devs just self-service to data. So I hope that this gave you sort of like a glimpse in how this potentially might work in the future. Obviously, it's not going to work for everything. Like if you're building something highly complex or that requires like high load or some type of sophisticated computation on the back end, maybe you do need to build your own GraphQL API. But my opinion is that in the future, most GraphQL APIs will be auto-generated. They will be configured. And just like you don't need to write custom C++ code when you add a new table to your SQL database, you're not going to need to write custom code to add a new object to your GraphQL API. Thank you.